today we're looking at compound interest. And Sam, you had mentioned that you weren't sure what was going on with this formula today. And I'm pretty sure we've looked at it. So let's look at it again. The formula for compound interest is a little more complicated than others. It looks harder than it really is. It starts with your total amount of money is equal to your original amount of money times 1 plus the interest rate divided by the number of compoundings annually taken to the number of compoundings annually times the number of times. And again, I know that sounds confusing and it looks confusing, but I have faith in you. So this amount total, or total amount. The second A with sub O is original amount. Then we're multiplying by 1 plus the interest rate divided by n, which is number of compoundings annually. That same number is put into the exponent along with t, which is time in years. Good luck reading that handwriting, but I think you kind of get the point. So if we read the original problem we have here, Sam invested $1,500 at 2.5% compounded semi-annually. Sam didn't touch this account for 3 years. How much money did Sam earn in interest, and how much was his total balance at the end of this time period? Okay, this is pretty straightforward. So the total amount of money that Sam would have after 3 years is equal to his original amount of money that he put in. Very often that's called the principal. In this case, we're talking about $1,500 times 1 plus our interest rate, which is 2.5%. Now we want to write that as a decimal. So that'll be 0.025. And we're going to divide by the number of compoundings per year. If this problem had said we compound annually, that means we compound once a year. So semi-annually means we compound twice a year. In this case, then I'll put a 2 in for n, and I place it inside the parentheses at the bottom of the fraction, and then again up here in the exponent. I'm going to multiply that by the number of years that we're working here, and this is 3 years. Okay, I want to clean this up before typing it into my calculator. And I do advise that you use a calculator with a viewing screen, if at all possible. In this case, I have $1,500 times 1 point. 0.025 cut in half is going to be 0.0125. So added to 1, I have 1.0125, and I'll raise all of that to the 6th power. So I'm grabbing my calculator right now, and I'm typing in 1,500, open parenthesis, 1.0125 raised to the 6th power. And I'm getting that the total amount, now I'm going to round to the nearest penny here because the context is money. So instead of going out to 4 or 5 decimal places, which makes no sense, I'm going to say $1,616.07. Now the question asked me 2 things. The original question said, how much money did Sam earn in interest, and how much was his total balance? We've actually found the total balance first. The total balance is $1,616.07. That seems to indicate that the interest alone would simply be the total amount you have at the end minus your original amount. In this case, it looks like we're looking at $116.07. Okay, so that's problem number 1. And that you should be doing chapter tests at the end of chapter 7 tonight anyway. So that looks a lot like question 8 and 9. Let's look at our next problem. Sam put $400 into an account paying 4% interest compounded quarterly. What was his balance at the end of 2 years, 3 months? All right, we're going to do the same thing here. And I'm going to encourage you to write down this formula every time you do one of these compound interest problems. In the sense that you're writing it down every time you're doing it, instead of just memorizing the formula, which is kind of silly because you'd lose it as soon as the test was over, you're using the formula over and over and over again, and that puts it into longer term memory, which is far more useful for us. The total amount of money Sam will have is equal to his original amount, or his principal, which is $400, times 1 plus his interest rate is 4%, which is a decimal is 0.04. Now we're compounding quarterly. And I hope you realize that compounding quarterly means you're doing it 4 times a year. So the number of compoundings is 4. That number goes here and here. 2 years and 3 months. So time is supposed to be written in years. Well, 2 is obvious. 3 months is 1/4 of a year. So I'm looking at 2 and 1/4, which I can write as a fraction as 9/4 of a year. Or 9/4 years, I probably should have said. Okay, again, I don't want to type this into a calculator. I want to clean this up first. The total amount is equal to 400 times 1 point. Now 0.04 divided by 4, it's pretty obvious, it's 0.01. So I'm looking at 1.01. If you look at this exponent here, I have 4 times 9/4. Take a wild guess what those 4s are going to do. Well, if you're guessing cancel, you're right. That 4 will cancel with that, and I'll have it raised to the 9th power. Now it's time to grab the calculator. And I'm going to type in 400 times 1.01 raised to the 9th. And I am going to get as a total number here. So again, it's messy. So total amount equals $437, and I'm rounding to the nearest penny, so 47 cents. Is that what they asked me to find? Yes, that was his balance at the end of 2 years and 3 months. So again, if it had asked you to find interest, you'd say $37.47, but this time it didn't. It asked for total balance. Anyway, I hope these 2 problems are instructive and help you to finish that chapter test tonight, Sam. Talk to you tomorrow.